Morning girls, I just said I'd put together a quick video there on the rules for assigning oxidation numbers. If you're following it in the textbook, it's there on page 196, 197, 198. But I'll just quickly go through it here just to give you a look at how it's done. So there are 7 rules for assigning oxidation numbers. The first one has to do with uncombined elements. And their oxidation number, or ON for short, is 0. So examples of that would be Fe, just on its own, 0. Or something like Cl, just on its own, it has 0. Or something like Zn, on its own, its oxidation number is 0. The second rule then has to do with ions. And this is another quite straightforward rule. The oxidation number for ions is equal to the charge on the ions. So for example, if you have Fe2+, then its oxidation number is going to be +2. If you have something like Cl-, its oxidation number is going to be -1. If you've got something like Fe3+, its oxidation number is going to be +3. The third rule then looks at compounds. And basically for this, it says that if all of the sum of the oxidation numbers of the elements should add up to 0 in a compound. So if you have a compound like NaCl, then the Na has a +1, the chlorine has a -1, and that adds up to 0. Same here in water, H2O, the oxygen has a -2, and the hydrogen each have +1. And we'll get into why that is in the next 2 rules, the hydrogen and the oxygen. So for compounds, the oxidation numbers of the elements needs to add up to 0 because there's no charge on the compound itself. So if we look at the next 2 rules, number 4, which looks at oxygen, basically, in general, always the oxidation number of oxygen is equal to -2. There are a couple of exceptions. So exceptions are peroxides. That's where there's 2 oxygens present. It's -1 in those. And in OF2. Where it's +2. So there are the 2 exceptions. Again, if you've got H2O, the oxygen is -2, each hydrogen then has a +1, giving a total of 0 because it's a compound. Except in the peroxide, something like H2O2. In this case, you've got oxygen as a -1 and the hydrogen as a +1. So that's an exception. The 5th rule has to do with hydrogen. And in general, always, the oxidation number of hydrogen is +1. Some of the exceptions are metal hydrides. Metal hydrides, it has -1. But for the most part, hydrogen is going to have a +1. So an example of that would be something like NH3, ammonia. Hydrogen has a +1, so the ammonia has a -3. Okay, looking at rule 6 then. Rule 6 has to do with halogens. That's group 7 of the periodic table. So halogens are -1. And their exceptions when bonded to something more electronegative, now since fluorine, which is the top halogen, is the most electronegative, atom, it's always -1. So in general, they are -1. Fluorine is always -1, but in certain circumstances, if chlorine, for example, is bonded to something more electronegative than itself, it has to adjust. If you look at rule number 7, so rule number 7 is for complex ions, and this is quite similar to the one number 3 for compounds. And the sum of the oxidation numbers adds up to the charge on it. So something like SO4 2-, well, the whole thing has to add up to 2-. Using our knowledge of the rules, oxygen will be -2. So that's 4 - 2 is -8. The whole thing adds up to -2. So that gives us +6 for the sulfur. Another example would be CO3 2-. Knowing the rules that oxygen is -2, 3 - 2 gives us -6. The whole thing adds up to -2. So that gives us the carbon as +4.